Good morning, children. I hope you all are good. Children, as I have already told you that in your syllabus, the manufacture of sulfuric acid is not there. We have completed up to the topic sulfur dioxide in group 16th elements. So today I'm starting with sulfuric acid. Sulfuric acid, the preparation of sulfuric acid is not there in your syllabus anymore as per CBSE, but the properties and the uses of sulfuric acid are important. Still, I'll just give you a general idea about the manufacture of sulfuric acid. Children, sulfuric acid, it is manufactured by contact process in 3 steps. There are 3 steps in the preparation of sulfuric acid. In the first step, sulfur or any sulfide ore is burnt in air to get sulfur dioxide. In the second step, sulfur dioxide is made to react with oxygen to produce sulfur trioxide SO3, and the reaction takes place in presence of the catalyst V2O5, that is vanadium pentoxide. In the third step, absorption of SO3 on sulfuric acid to give oleum takes place. Oleum is the purest form of sulfuric acid, or you can say highly concentrated sulfuric acid, which is one of the oxo acid of the sulfur. Sulfuric acid also is an oxo acid of sulfur, and the formula for oleum is H2S2O7. This is oleum. This oleum is diluted up to desired concentration to get the sulfuric acid of desired concentration. So, the process used in the manufacture of sulfuric acid is contact process. The reaction takes place in 3 steps. The first one is burning of sulfur or sulfide ore to produce sulfur dioxide. Then conversion of sulfur dioxide to sulfur trioxide in presence of vanadium pentoxide and oxygen. And in the third step, the absorption of SO3 on H2SO4 to give oleum. So, this oleum is diluted and we get the sulfuric acid. Now, children, you have to remember that the process is exothermic. The second step of the reaction is exothermic, reversible, and the forward reaction leads to the decrease in volume. Therefore, low temperature and high pressure are favorable conditions for maximizing the yield of sulfuric acid by contact process. Now, the sulfuric acid that is prepared by contact process is generally 96 to 98% pure. Now coming to the properties which is there in your syllabus, the manufacture was there, not there in the syllabus. Now see children, coming to the properties, you all must have seen sulfuric acid in the laboratory. It is a colorless liquid but is dense like a oil. So, sulfuric acid is a colorless, dense, oily liquid. You all must have seen in the laboratory. Number second is it dissolves in water with the evolution of large quantity of heat. That is why whenever dilute sulfuric acid is prepared from concentrated sulfuric acid, we never add water to sulfuric acid. Instead, we have to add sulfuric acid to water so that as the process is exothermic, so that the energy which is released is absorbed by the water, nor the beaker will break. Now, number third is sulfuric acid is a very strong acid. This you all know. Now, children, you have to remember that sulfuric acid is a strong acid. That means it can release H positive ion. Those substances which give H positive ion are acids. Now, sulfuric acid has got how many H positive? H2SO4. How many H positive are there? 2 H positive are there. Now, if we write the reaction for the ionization of sulfuric acid, then first of all this converts into HSO4 negative, and along with this, this is not negative positive, this is negative, HSO4 negative plus H positive. Now you have to remember that the Ka1 for this reaction is very high. Why is it high? Because it is a very strong acid, and for this, if we ionize this compound HSO4 negative, we get SO4 2 negative, and the value of Ka2 for this reaction will be very less as it is weaker acid. So you have to remember, out of H2SO4 and HSO4 negative, H2SO4 is stronger acid. So the value of equilibrium constant Ka is very high. I'm sorry children. Now you have to remember that sulfuric acid shows strong affinity for water. That means it absorbs water readily. Many of the wet gases, they are dried using sulfuric acid by passing the wet gas above sulfuric acid. Now children, sulfuric acid has got an ability of a strong oxidizing agent. You all know those substances which are actually acids, they oxidize the other substance. They take H positive from, they give their H positive. That means the substance that will take that H positive will get, just a minute children. Yes, it has got a strong ability to oxidize the other substances. Now coming to the uses. Sulfuric acid children, the first important thing about sulfuric acid you should know is that a country's industrial strength can be judged by the quantity of sulfuric acid it produces and consumes. Why? Because in almost all the industries, sulfuric acid is required. It is used in the manufacture of fertilizers, in the manufacture of paints, pigments, dyestuffs, in detergent industry, in the metallurgical process for cleaning of metals, and most important one is in the batteries, the storage batteries. It is also used in the manufacture of nitrocellulose products and the laboratory, as a laboratory reagent. This you all know. Now children, we have completed sulfuric acid. Next I am starting with the Oxo Acids of Sulfur. Children, previously in the previous year, Oxo Acids of Phosphorus were also there in the syllabus, but this year they are not there. So here you have to remember Oxo Acids. What is the meaning of Oxo Acid? If I am talking about the Oxo Acid of any of the substance like sulfur, then you have to remember, in an Oxo Acid, sulfur will form a double bond with oxygen and a single bond with oxygen and hydrogen. That is, a single bond with OH and a double bond with O. Now children, apart from these two bonds, other bonds can be a single bond between sulfur and hydrogen, a single bond between two sulfur atoms, and other bonds can be other OH bonds and other bonds. Now children, there are many oxo acids, but this year in your syllabus you have to study only the structures of oxo acids. Now I am starting from H2SO3. H2SO3. Now see, it is an oxo acid of sulfur, so sulfur will be present in the center, and as I have told you, double bond O is compulsory and one single bond OH is also compulsory. Now apart from this, what all things are left? One oxygen, two oxygen. That means one more oxygen is left, and what else? One more hydrogen is also left. One oxygen is left and one hydrogen is left. So what will happen? It will form a single bond with oxygen and hydrogen. Now what happens? You all know in sulfur's configuration 2 more electrons are left, so they will be present as a lone pair. So this is the structure of sulfurous acid, that is H2SO3. You should be knowing how to draw these structures. Number second, the second oxo acid of sulfur is sulfuric acid, H2SO4. Now in H2SO4 again sulfur is present in the center, a double bond O, a single bond OH. Now what else is left? One hydrogen is left and two oxygens are left. So one hydrogen and one oxygen will form a OH bond and another oxygen will form a double bond O. This is your structure of H2SO4. Now next is H2S2O8. H2S2O8. Now in this H2S2O8, one sulfur, second sulfur. Double bond O is necessary for both the conditions. Single bond OH is also compulsory. Now what all things are left? 2 hydrogens are utilized, 2 sulfur also utilized. Out of 8 oxygen, 1, 2, 3, 4 oxygens we have used. Now how many oxygen left? 4 are left. So how they will be arranged? Double bond O, double bond O, single bond O, single bond O, single bond S. This is the structure of peroxo disulfuric acid, that is H2S2O8. Now coming to the fourth oxo acid of sulfur, that is H2S2O7. What is the name of H2S2O7? Yes, it is oleum, the pure form of sulfuric acid. Just now I have told you about this, that it is manufactured by contact process. Now in this also you all can see 1 sulfur, 2 sulfur, double bond O, double bond O, single bond OH, single bond OH. Now see, 2 hydrogens are there, both the hydrogens are used. 2 sulfur are there, both the sulfurs are used. 7 oxygen, 1, 2, 3, 4. 4 oxygens are used. 5, 6 and 1, 7. Children, you have to remember the structure should be tetrahedral. The atom which is forming this oxo acid should be tetrahedrally surrounded by the other atom. Now, next oxo acid of sulfur is H2S2O5. H2S2O5. Sorry. It is H2SO5. H2SO5. Now in H2SO5, sulfur is present in the center, double bond O, single bond OH. Now sulfur is present, 1 sulfur, 1 oxygen and 1 hydrogen are used, 1 more oxygen and hydrogen are left. Now what else is left? 5 oxygen, 1, 2, 3 plus 2 oxygens more are left. So children, some of these oxo acids are unstable, they cannot exist, their structures are unstable and cannot be isolated. They are known in aqueous solution or in the form of their salts. Now children, this was the last topic of your group 16th elements. Now next I'm starting with the group 17th elements. Now children, the elements that are present in group 17th of the periodic table are fluorine, chlorine, bromine, iodine and astatine. Astatine is a radioactive element, so we will not be talking much about this. Now you have to remember these elements are also called halogens. Why they are called halogens? Because they are salt forming. They can form salts. Now the element fluorine has atomic number 9. Chlorine 17, bromine 35, iodine 53, astatine is 85. The general electronic configuration for these elements is Ns2Np5. For fluorine it is 1s2, 2s2, 2p5. For chlorine the outermost shell configuration is 3s2, 3p5. From bromine onwards there is an interference of d orbital also. So after this is 3d10, 4s2, 4p5 and so on. So the general electronic configuration is Ns2Np5. You all know that there we can accommodate only 6 electrons in the p subshell, but there are 5 electrons. That means they have 1 electron less than the stable configuration. Now coming to the occurrence, how these elements occur in nature. Children, this fluorine and chlorine, they are fairly abundant. They are present in more quantity on the earth, while bromine and iodine are present in less quantity. Fluorine is present in the form of insoluble fluorides like calcium fluoride, CaF2. Cryolite you can say is one of the ore of aluminium, and the formula for cryolite is Na3Alf6. This is an ore of aluminium. And now fluorine is also present in this ore, and apart from this it is also present in the form of fluorapeptide, and in small quantities it is present in soil, river water, the plants and the bones and teeth of animals. Children, you have to remember that the deposits of the dried up sea also contain the compounds like sodium chloride, other ores of chlorine, and you all know chlorine is found in water. Certain form of marine life also contain iodine in their system, like seaweeds contain iodine. They contain up to 0.5% of iodine. Children, now coming to the atomic and ionic radii. Now you all know that when we move from left to right in a period, the size of atom decreases because the electron is added in the same shell. Now fluorine is present at this corner, or you can say this group of elements, fluorine, chlorine, bromine, iodine are present at this corner. So they have the smallest atomic radii in their respective period. From fluorine to iodine it increases, but here they have the smallest atomic and ionic radii in their respective periods. Now coming to ionization enthalpy, as they have only 1 electron less than the stable configuration, so they have very high value of ionization enthalpy, but it decreases down the group. They do not have a tendency to lose electron. They have very little tendency, you can say. Now coming to the electron gain enthalpy. You all know electron gain enthalpy is the amount of energy released when an electron is added to the outermost shell. Now they have only 1 electron less than the fully filled configuration, so they have maximum negative electron gain enthalpy. That means when they get 1 electron, they accept the electron, they take the electron and give out a lot of energy as they become stable. They have only 1 electron less than the stable configuration, and the electron gain enthalpy becomes less negative down the group. But there's an exception. As I'm telling you that down the group the electron gain enthalpy becomes less negative. But if we compare the electron gain enthalpy of fluorine and chlorine, then chlorine has a more negative electron gain enthalpy compared to fluorine. Why is it so? This is an exception. It is because of the small size of fluorine. The small size of fluorine, because of small size of fluorine, there occur the inter-electronic repulsions. Fluorine is very small. The electrons which are present inside, they repel each other, due to which the incoming electron does not feel any attraction. So, you have to remember the negative electron gain enthalpy of fluorine is less than that of chlorine because of the small size and inter-electronic repulsions in chlorine. Now coming to electronegativity, it is the tendency to attract the shared pair of electron towards itself. They have very high electronegativity. Fluorine is the most electronegative element of the periodic table. They have the strongest tendency to attract the shared pair of electron towards themselves because they have only one electron less than the stable configuration. Now, I am starting with the physical properties. Now, physical properties, fluorine is a gas, chlorine is also a gas, bromine is a liquid, iodine is a solid. About astatine, we are not talking, it is radioactive metal. Now, fluorine is yellow in color, chlorine is greenish yellow in color. Bromine, you all must have seen also in the lab, it is brown in color, and iodine is violet in color. Children, next we have to start with the anomalous behavior of fluorine, but we'll continue with this in the next presentation. For today, thank you and Sai Ram.